Okay, for this question, we have y equals 2x squared plus 5 to the 7th times e to the 2x divided by the square root of x squared plus 8. We want to find dy dx. Now, you could use product rule and quotient rule, but that's going to get pretty messy. So instead, I'm going to use something called logarithmic differentiation. And I'm going to appeal to the rules of logs together with implicit derivatives to enable me to do this in a more reasonable manner. So here's what I do. I take the natural log of both sides. I have the natural log of y on the left. I have the natural log of that expression on the right. So we have natural log of y equals the natural log of all of this. And we know that the natural log of a over b is natural log a minus natural log b. So the right side is natural log of the top minus natural log of the bottom. So we get natural log y equals natural log of the top minus natural log of the bottom. We recognize that the natural log of the product is the sum of the logs. So my next line will be natural log of this first piece plus natural log of the second piece. Minus the natural log of x squared plus 8 to the 1/2, which I'm actually going to rewrite as x squared plus 8, square root, right? It is to the 1/2 power, because we have another rule of logs which enables us to pull the exponents down front. The 7 comes down, the 2x comes down, the 1/2 comes down. So that my next line will be natural log y equals 7 times the natural log of 2x squared plus 5 plus 2x times the natural log of e minus 1/2 times the natural log of x squared plus 8. So we have it here, but all we've done is algebra, and we are ready to go ahead and do some calculus. We're going to take the derivative with respect to x of each side. So here's where we are currently. So we'll take the derivative with respect to x of the left side. So that's the derivative with respect to x of the natural log of y equals the derivative with respect to x of the sum of those three pieces, and the derivative of the sum is the sum of the derivatives. So the derivative with respect to x of the first piece, 7 times natural log 2x squared plus 5 plus, well, what is natural log e? Natural log e is just 1. E to the first power is 1. So that's the derivative with respect to x of 2x. Natural log e is 2x times 1, or just 2x, minus the derivative of this piece, the derivative with respect to x of 1/2 natural log x squared plus 8. Again, the derivative of the sum is the sum of the derivatives. Enables me to simplify that side of the equation. Now I can also pull the constants out in front of the derivative operator. So before I actually do these derivatives, let's go ahead and rewrite it that way. So this first piece, derivative with respect to x of natural log y, pull the 7 out in front of the derivative operator. 7 times the derivative with respect to x of the natural log 2x squared plus 5. I guess we could pull the 2 out in front. You don't really have to. It's pretty easy to do without doing that, but for consistency's sake, I will. 2 times the derivative with respect to x of x minus, pull the 1/2 out in front, minus 1/2 times the derivative with respect to x of the natural log of x squared plus 8. Okay, well, where are we? We've gone to this point, and we need to talk about what the derivative of the log of a function is. So let's remind ourselves of some facts. Recall the derivative with respect to x of the natural log of x is 1 over x. Recall the derivative with respect to x of the natural log of something is 1 over the something times the derivative of the something. So if we use that idea, the derivative of the log of f of x is 1 over f of x times the derivative of f of x, also known as f prime of x. So let's keep that in mind. So those are basic rules there for dealing with logs. Now, what do I have here? The first one I have is the derivative with respect to x of natural log y. Okay, let's talk about that one. What is the derivative with respect to x of natural log y? It's 1 over the something, 1 over the y, times the derivative with respect to x of y, which is 1 over y times dy dx. So the derivative with respect to x of natural log y is 1 over y dy dx. Equals 7 times the derivative with respect to x of the natural log of 2x squared plus 5. Let's do that one. So the derivative with respect to x of the log of something is 1 over the something times the derivative with respect to x of the something. The something being 2x squared plus 5. So the derivative of the log of 2x squared plus 5 is 1 over 2x squared plus 5 times the derivative with respect to x of 2x squared plus 5. So what do we get? We get 1 over 2x squared plus 5 times the derivative of 2x squared plus 5 is 4x. So we'll simplify that to say that it's 4x over 2x squared plus 5. And that's this piece, the derivative of the log of 2x squared plus 5, 4x over 2x squared plus 5. Plus 2 times the derivative with respect to x of x, that's just 2 times 1, of course. The slope of x is 1, or the slope of 2x is 2. Minus this piece, 1/2 times the derivative with respect to x of the natural log of x squared plus 8. Let's remind ourselves of that. The derivative with respect to x of the natural log of x squared plus 8. The derivative of log of something is 1 over the something times the derivative of the something. So it's 1 over x squared plus 8 times the derivative of x squared plus 8. So we get 1 over x squared plus 8 times 2x, and the result is 2x over x squared plus 8. So let's go ahead and put that in. So we get minus 1/2 times 2x over x squared plus 8. And let's do some simplification here if we can. That would be nice to see. What are we going to get here? Well, left-hand side is still 1 over y dy dx. 7 over 1, right? That's 7 over 1 times 4x, 7 times 4x, 28x over 2x squared plus 5. Plus 2 times 1 is 2 minus 1/2 times 2x. Well, that would just be x over x squared plus 8. And remember, our goal is to solve for dy dx. That's what we're looking for here. So how am I going to find dy dx? I've got 1 over y times dy dx. So I need to multiply both sides by y. Multiplying both sides by y will enable me to solve for dy dx. So my next line will be dy dx equals y times all of that stuff on the right. So 28x over 2x squared plus 5 plus 2 minus x over x squared plus 8. But that's not really an answer because my answer still has a y in it. Now, what was y? Remember back from our first page? This was y, right? I'm going to go ahead and I'm going to replace that y with 2x squared plus 5 to the 7th times e to the 2x over the square root of x squared plus 8. So we know that from before. So to finish this, my final answer will be dy dx equals y. This 2x squared plus 5 to the 7th times e to the 2x divided by the square root of x squared plus 8 all times all of this stuff, 28x over 2x squared plus 5 plus 2 minus x over x squared plus 8. Now, you certainly could rewrite this a whole bunch of ways using algebra. I'm not terribly inclined to do so. I believe I will call that my final answer.